Okay, let's look at this question here, which was taken from the year 1999, paper 1, question 1 of the further math paper, I believe. So I think this is taken from one of the school tutorial. So the curve C has equation of y equals to x squared plus 5, where lambda is a non-zero constant. Obtain the equation of the asymptotes of C. I think this is not an issue, just do a long division, then we will be able to find the oblique asymptote and also the vertical asymptote. From here, what we're going to do is just multiply by 1 over lambda, or x, right? Then this will be x squared plus 1 over lambda x. After which we have got this guy will be to get negative lambda 1 over lambda x, we just multiply by lambda square. Okay, so this will be here. Then we just minus it off. Then we'll get 5 plus 1 over lambda square for the remainder. So I guess to find the oblique asymptote shouldn't be an issue. This will be the oblique asymptote OA. Then to get the vertical asymptote, we just need to equate this to 0, right? We can't divide by 0. So these are the two equations of the asymptote. Okay, that's about it. Then we're going to look at part 2. So we're told to show that C has exactly 2 points at which dy dx is 0, meaning to say this is stationary value, right? The stationary value is equals to 0 for this case here, where you have 2 points, x, exactly 2 points there. So we just dy dx and just solve for 0 and show that is always 2 points. So we could show that it's always we have two real roots always. So we can either complete the square or we could just use b squared minus 4ac to show that it's at least 0. Using quotient rule, minus u dv dx, which is lambda. Okay, so this case here, I got this expression here. So I expand and just simplify the numerator. So when dy dx equals to 0, I know the numerator will be 0, right? But here, I'm just going to use a discriminant. So discriminant is b squared minus 4ac. That will give us 4 plus 20 lambda square. So obviously this is always 0. So since discriminant is always 0, meaning there are always at least there are always two distinct roots. So this is to show the discriminant is more than 0. Cannot be equals to 0. I mentioned wrongly just now. Essentially, we want to show is always having two real roots. Okay, there you go. You have C has exactly 2 points at which dy dx is 0. Let's look at part 3. So for part 3, sketch C, the case of lambda bigger than 0, and separate C where lambda is negative. Okay, I think this is interesting. I'm gonna let my lambda be, let's say, alphabet A. Okay, so this case here, you just use your GC here. Then what I'm going to do is actually just store, let's say, A as a value of 2, because lambda is positive, right? You're going to just put 2 storage of A. So alpha A here. So where's my A? A is here. This green color one. Okay. So A is 2 now. So what I'm going to do is I'm going to go to my GC and just plot this graph with my lambda as A. And with x squared. So here, x squared. So that later we can just flip to a negative one. So the alpha A. Then I'm going to put this as x plus 1. Okay, A can be any value. Then we know that our oblique asymptote is 1 over ax minus 1 over a squared. So I'm going to just 1 over a. I put x here. This is a line equation. Then minus 1 over a squared minus 1 over a squared. Okay, then this is it. So obviously, I always tell my students to just put this as a dotted line here. Just go down and just put it here. Press OK. Then I'm going to go graph. Okay, so I'll zoom standard first. So this is the shape that I got. All right, so this is when A is 2. So you're just going to plot this graph. So like I always tell my students, draw for rational functions, draw the asymptote and then the oblique asymptote. Then the last thing that you want to draw is actually the axis. Okay, so this is what I meant. So draw the asymptotes first, then after which draw the shape. The shape is obviously like that and like that. Then only lastly you draw the what do you call it, the axis. Okay, it will always work. So I'm gonna just use my GC here, just adjust my axis accordingly. Okay, I know that my vertical asymptote is. Okay, label my asymptotes, then after which draw the axis. So I'm just draw the axis here. I'm just gonna model my axis here. Okay, yeah. So this is the shape here. When lambda is bigger than 0, you get this graph here. Then we, on a separate diagram, draw lambda is less than 0. So what I will say is, with what we key in GC just now, okay, I'm going to just quit to the main menu. Then now my A, I'm going to put -2 storage to my A here, alpha A. Press enter. Now my graph will look different, okay, on the other side. So obviously it's going to look the same. So same thing. It's just yeah, I'm going to draw the asymptotes first, then the curve, then only lastly the axis, okay? So let's do that. Sketch the asymptotes first, then the shape. Label the asymptote, then you put in the axis in. So this is the shape that you get, okay? So separate diagram, we sketch it. So let's look at part 4. Find a set of value of lambda for which this line and C has at least one point in common. Now, y equals to 4x is actually a fixed line. So I could see that from this diagram here, if I were to draw a y equals to 4x, it will be a line passing through the origin, right? Okay, here and here as well. Okay, but the thing is, you wouldn't know how steep is this. It may cut this as well. So I mean, the 4x can be like that, right? Okay, so I think the thing is, what I'm trying to say is, it's not so easy to visualize the lambda. I don't think it's easy to see the lambda here, whether it cuts or not. So I'm going to use secondary school method. I'm going to just equate this into this guy. Then we use lightly can reduce the quadratic equation. Then after which you can just solve by using the discriminant. From here, it's just a secondary school equation here. I'm going to just cross multiply, then we're going to solve it. But you just have to take note that x cannot be equal to -1 over lambda, okay, because then the denominator will be 0. Okay, don't make the issue, just expand, then we'll just move all the x squared to the other side. So here you go. So you want at least one point in common, so I need at least one real solution, right? Yeah, I need to make sure the discriminant is at least 0. Then I'm gonna expand this. From here, what we get is here, divide by 20 both sides. We'll get this guy. Okay, then look at this, for lambda is at least 1/5, so lambda is equals to 1 over 20. Okay, that's about it. Yeah, okay. So this is how I do this question here proficiently. If you have any questions at all, please do let us know. See you in the next question.